Okay, welcome back, kiddos. Now we are moving on to unit number 11. We're going to talk about arc length and area of sectors. All right, so let's first get into arc length. What does that mean? Well, imagine if we have a circle, okay? Um, the arc length is a portion of the circumference. So we know all the way around is called the circumference. Okay, so what we can think of, since it's a part of that, so we can think of it like that, we can think of it like crust of a pizza. Okay, so we can think of it as the crust of a pizza. All right, so once we know that it's a circumference, then let's talk about that circumference formula. So the circumference formula is going to be 2 pi r. Okay, so that's what it is for a circle. All right, so you can use the measure of the arc in degrees to find its length. So that's what we're going to use. We're going to think of the arc measurement, which we've been studying, over 360 degrees, is going to be equal to the arc length over that circumference formula. And we said that was 2 pi r, or you might have heard of it previous as pi d, with d being the diameter, right? We know 2 times the radius is equal to the diameter. So both of these are the same, but we're going to use this one right over here, 2 pi r, because that's going to make more sense for what we're doing. All right, so that's the setup that we're going to use. We're just going to use that measurement of the arc to find its length. So now that we know that, let's go and get right into some practice on that. Okay, so let's look at this problem right over here. It says, in this circle, with the measurement of angle EFG is 36. So EFG, let's go ahead and trace that out. EF to G. Okay, so that angle is 36 degrees. Okay, so we know that's in degrees. Let's go ahead and put a 36 there, just so we know what's going on. All right, so then it says EF is 11 units. Okay, so EF, so this right over here is 11. Let's go ahead and mark that with 11. Okay, and they want us to find the length of arc EG. Okay, so let's go and kind of scribble the arcs like we've been doing. So that's what they want us to find, is the arc. So keeping that in mind, let's think about our setup. Okay, so we just said we're going to set this up with a proportion. So let's go and set it up with what we know. We know a proportion equals a proportion. So we said on this side, it's going to be the arc measure over 360 degrees. So the arc measure is actually, that's the length. Let's think about that. Where's the vertex? Okay, on this one, the vertex is right there. So if it's at the center, then we know the angle equals the arc, right? So if this angle over here is 36 degrees, that means this arc measurement is also 36 degrees. Okay, so that's where we're going to use our information from previous lessons. So now on the bottom, we said it's always going to be 360 degrees. So let's put 360 over there. Okay, so then on the top over here is the arc length. And the arc length is what we're trying to find, right? We said that was x. So let's go ahead and put that for right over there for x. And then we said circumference formula, which we said was 2 pi r, right? Make that a little smaller so we can see it. We said the circumference formula was 2 pi r. So let's go and put that 2 pi. And check this out. Instead of r, I'm going to put something else in place of r, right? We know that 11 is our radius, right? So that's what else we know, is that r is equal to 11. So let's go ahead and put 11 right over there in place of r. Okay, so let's go ahead and highlight that so we remember that that's where we got that from. So now that we have it set up, now we can remember that we just cross multiply, right? That's the hardest part, is just setting it up. And then we can cross multiply. So that times that equals that times that. So we can start wherever we want, right? But I like to start with my variable terms first. So I like to work with the x. So 360 times x is just going to be written as 360x equals, okay? Now let's look at what they want our answer in. On this one, they want to the nearest hundredth. Okay, so that means they want a decimal answer, right? Okay, well, what do we know about pi? Okay, so actually, let's go and write this down. So it's going to be 36 times all of this, right? So 36 we can put that in parentheses, times, actually, we can just put this over here, times 2, right? And then times pi, and then times 11. Okay? Now, here's the deal. What is pi? Okay, so here's what we have to remember is that pi, all right, that symbol is just equal to 3.14152, and then some, or 3.15, right, actually. And then a bunch of numbers, and actually never stops, right? So since it never stops and it keeps on going, we just round. A lot of times you'll just see it as 3.14, but instead we just put pi. So instead of writing 3.14, we just put pi. So these are all numbers, 36 times 2 times pi times 11. So since those are all numbers, we can just put all that in our calculator. Okay, so we know that's going to be 360 that we're going to divide by. So if we're dividing that by 360, I'm just going to put that whole thing into my calculator just like that. Okay, so if I do that, these 360s cancel out. So x is approximately, now 100th means 2 decimal places, right? 2 decimal places for that. All right, so that means it's going to be approximately 6.91. Okay, so that's all we do. Once we set it up, we're just going to use Desmos and our calculator to find our answer right over here. We're just going to type that in, and that will give us that as an answer. All right, so keeping that in mind, let's keep it moving on to our next one. Now, this one is a little bit different, and I'll show you why. Okay, it says in this circle, G, right, in circle G, and we know G is the center, so that's how we call it circle. GH is equal to 3. Okay, so GH. So GH is right over there, and that's equal to 3. And what is that? That is our radius, right? So that tells us that the radius is equal to 3. Okay, so it says the measurement of angle HGI is 80. So let's trace that out. HG to I, and we said that was 80. Okay, so keeping that in mind, that tells us what our arc measure is, right? So it says find the length of HI. Okay, so we're just going to mark that with X. HI, which is this arc right over here, right? Because we know it says arc right over here. So that is what we're trying to find the length. So let's just mark that with X. All right, so now that we have it set up, let's go and use our formula just like we talked about, right? So let's go ahead and see, what did we say our formula was? Okay, so we said our formula was arc measure over 360 degrees. So the arc measure is the same as this, right? So if that's 80 degrees, we know that has to also be 80 degrees, right? Oh, what happened here? Okay, 80 degrees, right? So if that's 80, we said that was always 360. Okay, so on top of here goes the arc length. That's what we're trying to find. So let's put an X over there. And then we said 2 pi. And now we said our radius was 3. So let's just put a 3 right there, right? Okay, so now we know what to do, right? Let's just go ahead and just do our cross multiplication, right? So this times this equals this times this. So we're going to get 360x equals, now this time let's just write everything down because they want us to answer as a fraction times pi. Okay, so what that means is no decimal. Okay, so no decimal answers. They want the answer to have something with pi in it. So we can't just type this whole thing in. But so let's just do this. Okay, so we know this is 80 times all those. So just for a moment, let's just go and write down the numbers. So we know 80 times 2 times 3, and then let's put the pi at the end, right? Because I think you will agree this is this 80 times all of this, 80 times all of that, right? So we didn't leave anything out. Now, let's just put this into our calculator. Okay, so if we put that into our calculator, that's going to be equal to 480 and then pi, right? So let's do that and then bring that down. So that's 360x. Okay, So now that we see that, now we know what we're going to do. We're just going to divide, right? We're going to divide that side by 360. You're going to divide that side by 360. That cancels out. So here's the critical thing we need to make sure that we're using our Desmos for. Okay, so as we see over here, what we're going to do is we're going to put 480 divided by 360 into our calculator. Okay, we're not going to put that pi in there because we know our answer wants to have pi as the answer. Okay, so I'm only going to put in that 480 over 360. Okay, so then it gives me this. But they said they want it as a fraction. So remember, we're going to type this button right over here. Okay, make sure you push that, and then that will give us x equals 4/3 pi. Okay, so once we use that symbol right over there, that will give us our correct answer. So make sure that you do that, and that's our answer, 4/3 pi. All right, so keeping that in mind, let's keep it moving. All right, so next on this, see if you can set this one up on your own. All right, so it says in circle D, the measurement of EDF is 20. So let's mark that EDF, and we said that was 20 degrees. Okay, so it says the length of EF is 13 over 9 pi. So EF, and that's an arc, right? So that's an arc measurement, right? This right here tells us arc measurement is 13 over 9 pi. So 13 over 9 pi, right? Make sure the pi goes to the side. So now they want us to find the length of DE. Okay, they want us to find this right over here. So that's our x. Okay, so no big deal. We're still going to use our same setup. So once we know how to problem solve, we're just going to write in our answer information. All right, so let's kind of get all this over here. So we know on top it's going to be the arc measure over 360. Well, if that's 20, we know the arc measure is also 20, right? So that's going to be 20 over there. And we said over 360, right? Okay, equals the arc length. Okay, so the arc, we want to find the length of DE. So the arc length is that right there. We're going to put that right over there. I know that looks a little weird, but 13 over 9 pi. I know it looks weird, but we're just following the math, right? Okay, so now what goes over here at the bottom? The bottom is the circumference formula, so 2 times pi times r. Okay, well, the radius is DE, right? So the radius is equal to x, right? So let's write that in, 2 pi x. All right, so now that we know that, that looks really weird, right? Let's just follow the math just like we've been doing, okay? So we said we're going to cross multiply, right? So this times this equals this times this. All right, so let's do this times this first because that one has the x in it. So we know 2 times 20 gives us 40, right? And then pi x, right, equals, okay, now this times this, let's just put that over there, okay? So 360 times 13 over 9 times pi. So 360 times 13 over 9 pi, right? Okay, so I know that looks really wild, but that's what we just did, right? And I can put, let me just put, instead of the 40, let me put the 2 times 20 just to make sure that we're clear on what we're doing here, right? So we said we know that's going to be 2 times 20 times pi times x, right? 2 times 20 times pi times x. All right, so now let's just think about what we're trying to do. We're trying to get x by itself, right? So we're going to divide by everything that's over here. So let's just do that. So I'm going to divide by the 2 and the 20 and the pi, right? Because I want just the extra remain. I divide by whatever I want to leave, right? So I'm going to do the same thing over here, all right? So I'm going to do 2 times 20 times pi, okay? So stick with me. I know that looks weird and gross, but that's okay. We're just going to follow the math, right? So over here on the left side, what happens? This 2's cancel out, right? The 20 cancels out. The pi's cancel out also, and we're left with just x, right? Equals, now let's do some thinking over here. What happens with the x, the pi's over here? Well, those cancel out, right? So we can just put in all of this into our calculator right over there. Okay, so if we put that into our calculator right over there, because these are all just numbers, so 360 times 13 over 9 divided by 2 times 20, right? So you can also put that in parentheses if you are just typing that in straight. So that's going to give us the answer is 13. Okay, so we get a nice little answer like that. Oh, the main thing is knowing what to type in. All right, so keeping that in mind, let's go ahead and look at our next problem. All right, so final problem that's right over here. Let's kind of move this guy out of the way. Oop. Uh-oh, this guy doesn't want to go out of the way. All right, so let me pause this video. We'll come back to him. Okay, so I got that figured out. So now let's go and look at this one right here, and let's go to the next level. So this one, let's look at this information. It says JK, in circle J, JK is equal to 2. So JK is this right over here. Well, what do we know that is as? That is the radius, right? So the radius is 2, excuse me. The length of arc KL is 7/9 pi. So this arc right over here, the length is 7/9 pi. Okay, so that's a little tricky. We're going to think about that in a moment. And then the angle that they want us to find, they want us to find the measurement of angle KJL. So let's just kind of highlight that in KJL. So that's what they want us to find, right? They want us to find that angle measure. All right, so let's go ahead and use what we know, right? The only thing we really know is that we can use our formulas that we've been practicing. So let's use those and get right to it. Okay, so stuff out of the way. All right, so we know that on top, let's just kind of look at this one right over here, right? So we know this one right that we just worked on. We said the measurement of there in degrees is over 360. Well, what is this? Is this in degrees or is that length? This is length, right? So that's length, right? So length goes right over here, right? Measurement goes right over here. Well, we don't know that because it's going to be the same as the central angle, right? So that's what we're trying to find. All right, so that's the crucial thing, is where we set everything up. So the length, since the length is over there, that's going to go over there, right? That's going to be that 7/9 pi, right? And then we know that that's going to be 2 pi times r, right? We said r is 2, so let's just go and put the 2 over there. Okay, so now that we got it set up, let's just go and do our cross multiplication, right? So that times that equals that times that. All right, so let's do the one with the x first. So 2 times 2 is 4 times pi times x, right? So let's write that down. 4 pi x, right? Equals, and let's just write this down because these are all just numbers. 360 times 7/9 times pi, right? So 360 times 7/9 and time. We can just put pi. We don't have to necessarily put times pi. It already knows. All right, so now let's think about what we're trying to do. We're trying to get x by itself, right? So we need to get rid of these two that are multiplying. So the opposite of multiplying is divide, right? So 4 pi. Let me change that. All right, so we're going to divide both sides. If I divide the left side by 4 pi, I got to divide the right side by 4 pi as well, right? Okay, so keeping that in mind, let's just check this out real quick. Over here, let's just do the algebra. We know the 4 pi and the 4 pi are going to cancel, right? So the 4's go away, the pi's go away, and we're left with just x, right? Okay, so now we can think of it like this. These 2 pi's cancel out, right? Or the whole thing are just numbers. Even though that's a pi, we know all those are values, right? That's the same thing as 3.14. If we type all that into our calculator, that's going to give us a nice, beautiful number of 70 degrees. All right, so that's it on that first page. This is how we find the arc length, so make sure that you do the practice right now in Delta Math before we move on to the next page. Okay, so let's go ahead and wrap this up now, and we're going to talk about area of sectors. So we talked about what arc lengths are. Now, area of a sector is like if we had like this would be like a slice of pizza. Okay, so if it's a slice of pizza, we can think of it as a region bound by two radii and their intercepted arc. So that's the technical way of saying that we have these two radii, right? And then the intercepted arc is right there. And so we're just talking about like a slice of pizza, right? So the area of a sector is part of the area of a circle. Okay, so we just need to remember that area formula, which for a circle is going to be pi times r squared. Okay, so it's just a little bit different setup because we're talking about area. So now that we know that, let's just go and get right into some examples. Okay, let's do it. All right, so it says in this circle with measurement angle DEF is 68. Okay, so let's write that in. DEF, okay, that's 68, right? Okay, DE is 12 units. So DE is 12. We know that's our radius, right? Our radius is equal to 12. Okay, find the area of sector DEF. So since we're finding the area, we know we're going to use the area formula, not the length formula, circumference formula. All right, so found to the nearest hundredth. So we know we're going to find a decimal answer with 2 decimal places, right? That's what that hundredth means. Okay, so let's keep that in mind. Let's just go and set it up. So we know it's going to be the arc measure over that, right? So if it's 68 for a central angle, we also know that that's also going to be 68, and we know it's going to be over 360. So then we said the area of the sector. That's what we're trying to find, right? That's our x. So let's go and put that over there. And then we said pi times the radius squared, right? So instead of that radius, we're going to put 12, right? We're going to put that 12 right over there. Okay, so now let's just do our cross multiplication. Okay, so 360 times x times that times that. So that's going to give us 360x equals pi times 12 squared times 68, right? All that's being multiplied. Okay, so now we're going to divide that side by 360, divide that side by 360, right? And if thinking about it, we could type all that in, but we don't need to right now because we know we're still going to divide by 360, right? So if we know what we're getting to, then mathematically you can help us out, right? Because now I know that all I have to do is just type all that into my calculator. If I do that, we know that we are rounding to the nearest hundredth, so I know I need 2 decimal places. So it's going to be x is approximately 85.45. Okay, and that is our answer. All right, let's keep it moving. Okay, in circle N, NO equals 3. Okay, so NO is equal to 3. We know that that is our radius, right? Radius is equal to 3. ONP is 160. ONP, that gives us 160. Okay, find the area of the shaded sector. So that's going to be our X. Now this one, they want it as a fraction times pi, so not a decimal. Okay, that's what it tells us, right? Okay, so let's set it up. Okay, so we know it's going to be 360 over here. We know if this central angle is 160, we know that the angle measurement is also, arc measurement is also 360, right? So we're trying to find the area, right? Remember, that's what we're trying to find, so we're going to put that over x, and then we know it's going to be pi times the radius of 3 squared, right? So let's just do the math. So we said 360 times x, right, gives us 360x. Equals 160 times pi times 3 squared. So 160 times pi times 3 squared. Okay, we're going to divide by 360. Divide by 360 cancels out. X is approximately, right? So since we knew that all these are just, all these are just values. But the critical thing is we want to keep it in terms of pi. So let's just type in everything else. So we're just going to type in this and this and this. Okay, so in other words, this is what we're going to type in, 160 and then 3 squared and then 360. And then we're going to keep the pi. Okay, so if we do that, if we type all that into our calculator, that means it's going to be x equals 4. And then we bring down the pi right over there. So that's our answer. X equals 4 pi. All right, so that's what we need to keep in mind on this one. Because they don't want a decimal, we have to keep the pi out of it. Just type everything else into our calculator. All right, let's keep that in mind. Let's keep it moving to our last couple problems. Whoa. Okay, so it says over here, in this circle, DCE is 135. DCE is 135. Okay, the area is 24 pi. Okay, find the length of CD. So that means this is what they want us to find, and that's our radius, right? So our radius is equal to x. That's what we're trying to find. So now that we know that, let's set it all up. Okay, so we said that we're going to have the arc measurement on top, right? So if that's 135 for our central angle, then we know that arc is also 135, right? Okay, so if that's 135, we know the total is always going to be 360 degrees. Okay, so then over here, since we're talking about area, then we're going to do the area of the sector, which they give us is 24 pi. So 24 pi. Okay, and then we know that since we're dealing with area, we're going to use our pi r squared formula. But we said the r value is x, right? So we're just going to put x there instead of r. Okay, so keeping that in mind, we're just going to now follow the same procedure. I know that looks weird, but let's just follow the same procedure. We're just going to do our cross multiplication. So I'm just going to do that, and then that and that. Okay, so I like working with my x term first, so I'm just going to do this first. So check it out. I'm going to put the number for 135 times pi times x squared. So we're going to put the number first, right? So 135 times that is 135, then pi, then x squared. Okay, so that's what we get with that. Okay, times 360 times 24 times pi equals 360 times 24 times pi, right? And we could just use that dot there, or we can use parentheses, as long as we know it's not a decimal, right? Okay, so now we just keep on doing the math. Let's think about what we're trying to do, though. We're trying to get to x, right? But we have x squared, and we have it times 135 and pi. So we want to get this by itself first before we deal with that squared, right? So we need to get rid of everything else, right? How do we get rid of it if they're multiplying? That's right, we divide. What do we want to divide by? We always divide by what we want to get rid of. We want to get rid of the 135, and we want to get rid of the pi, right? We don't want to get rid of the x squared yet because we're going to work with that last. So if we do that over here, the reason why we do that, right, is like we said, we want to get rid of those, right? So that cancels out and that cancels out, and we're left with just x squared equals. But if we do it to the left side, then we have to do it to the right side as well. So anytime we divide on one side, we typically go ahead and immediately do it that way. I just wanted to make the point with that. So I'm going to divide that by 135 and the pi. Okay, so now we remember that this pi is just a substitute for 3.14 and change, right? So we can put all that into our calculator. Okay, so if we put all that into our calculator, we are going to get a sum total of 64. And so that whole thing comes down to 64. Now, some of y'all may have said, okay, well, I can cancel those out, right? And then you could just type in these other numbers. That is correct. And you still would get 64. Okay, so it's great if you use as much math as you could. And I understand putting that in the calculator. Now, we don't want x squared. We want x, right? So how do we do that? Think about what we're trying to get to, right? We're trying to get to x, right? But we have x squared. So what happens to go from here to here? Well, from here to here, we square it, right? So to go backwards the other way, we're going to unsquare, which is the same thing as taking the square root, right? So to go from here to here, we would take the square root of that, and it would give us x, because these two would cancel out. The square root and the square cancel each other out. All right, but if we're going to do that to the left side, we have to do it to the right side as well. So you may know in your head the square root of 64 because we've been practicing. Otherwise, just type that in, and we know that is 8. Okay, so that's it. So we take a complicated problem. All we have to do is set it up correctly. Once we do our cross multiplication, we can put all that into our calculator. All right, let's do our last one. See if you can get this one maybe on your own. This is our last one, so it's typically the most difficult. Let's see what you got. All right, hopefully you tried it. All right, at least try to see what you can do. Let's read it through it together. Okay, so it says in this circle D, right, which we know center is D. Okay, DE equals 8. Okay, so DE, let's go and trace that in. D to E, and we're going to put an 8 there. Well, what do we know about DE? DE is the radius, right? So we can say radius is equal to 8. It gives us the area is 24 pi. Okay, so it's similar to the question that we were working on last time, except for they're asking for something different this time. Okay, now this time they're asking to find the measurement of EDF. So since that's an angle, let's go ahead and trace, highlight that one, EDF, right? And that's what we're trying to find. So we can put an X there, right? That's the value that we're trying to find. Okay, so if we do that, now that's the only information we have, right? So let's go and set it up. All right, so we know that over here goes the arc value, arc measurement in degrees. Well, that would be this, right? Since it's a central angle, what does it tell us this is? It is x, right? Because if this is x, this is always the same, right? What goes over here? We know it's always 360, right? And so then what goes on top? The area of this sector that they shaded, which is what we're working with, right? Which is 24 pi. Okay, and then the last thing is what goes on the bottom? That's right, pi times the r, which is 8, right? Radius times 2 squared. That's it. All right, so see if you can at least do the next mathematical step, if not the whole thing. Pause as you go along, unpause, see if you can get this last one. All right, so that times that, and that times that. So let's do the x first. So that's going to be, we can just put x, pi, and then 8 squared, we just talked about it, was 64, right? Equals 360 times, we can put it in parentheses, 24 pi, right? Okay, now, once again, now what are we trying to accomplish? We're trying to find the value of x, right? So we want to get rid of the other stuff. What's mathematically, what do we do next? Go ahead and go through the next step. Hopefully you said divide by this pi 64, right? And if I do it over there, we got to divide this side by pi 64. Okay, so cancel out. We'll go cancels on the left side. Okay, bring down equals. Now I wanted you to think on this level. Cancel out what would cancel on the right side. That's right. These two would cancel out, right? Anytime we have the same thing on top and bottom, they would cancel. So you could cancel those if you want to or not. It doesn't matter because mathematically it's the same thing, right? So if we just type that whole thing in with or without those pi's, we're going to get the answer of x equals 135 degrees. Okay, so that's the basics of it, is that we just have to set it up correctly, as we talked about with basically all of the things we do, is just setting it up correctly. And now I think we feel more comfortable with the math, even these more difficult ones down here. And so on this one, you just remember that we're dealing with the area formula when we're dealing with the area of a sector. Okay, and then on our previous page, when we're dealing with the circumference, then we use the circumference. Okay, so get to it. If you have any questions, please let me know.